morning, everyone. Welcome to the focus group on steering your customer journey using behavioural modelling to understand the why behind people's behaviour, so you can choose when to act to steer their journey in a positive direction. My name is Kirk and I'm a consultant developer at Apteco. In the first half of my career, I worked as a statistical data analyst, particularly using SAS. And I'm now working on the modelling techniques within Apteco, bringing AI capability to the product, thinking of AI also as augmented intelligence, enabling you as a user to do more by automating analysis and encapsulating expertise so that more people can get more value from their data. I stole my favourite slide from last year's talk, which you may have seen, to explain behavioural modelling. This involves first identifying customers with a particular behaviour of interest, perhaps people who have responded or unsubscribed, and then characterising what's different about their preceding behaviour, so that as you look forwards, you can recognise the same features and patterns in current customers, and so choose and predict when to intervene with a marketing action, and so steer people in a positive direction. This slide I also stole from a new e-guide on behavioural modelling, which you can download from the from Apteco portal. And this is going to form the basis of today's session. I'm going to start with an introduction comparing various analytical techniques. We'll also have a live FastStats demo of the main sections. And also, if you have any questions, please use the chat, which Ian is monitoring. And if you can direct them to him, he will see and maybe answer some during the session, or if there's time, I'll do that at the end. The session is also being recorded and will be available online with the other conference resources via the Apteco portal. Behavioural modelling combines two fields, customer journey analytics and predictive modelling, and it enables us to go beyond what has happened to understand more why did it happen. So I'll start by looking at some of these buzzwords and different techniques. And broadly speaking, analytical techniques can be divided into descriptive and predictive techniques. Descriptive looks at what, and predictive looks at why things happen. So, for example, segmentation describes your customers, what the different types are, whereas predictive techniques such as PWE or decision tree, they try to understand why things have happened. The type of data used in the technique could be either static or dynamic, where the dynamic introduces a time element of when things have happened. The FastStats segmentation tool describes what the common journeys are over time, often shown visually in a Sankey diagram. So combining the dynamic when and the predictive why, that gives us behavioural modelling, which enables you to go beyond choosing just who to target, but also when. So in a bit more detail, descriptive techniques such as segmentation, they focus on the differences within a single group, such as your customer base, and the segmentation identifies features that distinguish individuals from each other. So, for example, here, this person is high in recency, this person high in recency and value, hence the color coding, someone who is a frequent customer. And the segmentation will create partitions to subdivide and create groups within your customer base. On the other hand, a predictive technique focuses on the differences between two groups. For example, a base who have been sent a campaign, and then a second group, the analysis who have responded. The predictive technique will identify features that distinguish these groups from each other. For example, people with high recency are more likely to be responders in this example. Those who don't respond are perhaps the less recent customers. So the aim of a predictive technique is to create rules or scores to explain the groups, and for example here that the more recent customers are more likely to respond. Looking at a dynamic segmentation, this might be based on journeys, based on events over time, and a segmentation will still be identifying common groups. In this case, the common journeys, perhaps people who have made a direct purchase or visited a website, followed that by a purchase. And again, it's creating those rules and finding those common journeys. Whereas behavioral modeling is using the dynamic element in two ways. Firstly, to identify the customers that we're interested in selecting based on a journey. And then secondly, creating features to compare these groups, which incorporate time by assessing trends in their behavior or perhaps sequences of events. So let's look at a few examples before going on to see how things work. Behavioral modeling could be used to characterize who has lapsed or unsubscribed, recognize those patterns in current customers, and so act to avoid other people going the same way. Or on the positive side, recognizing historic patterns in good supporters could help you identify which supporters should be encouraged now to make a donation. Product level data can also be used, enabling patterns in your sort of retail data in combinations of products, enabling that to be used when planning promotions. The example we focus on today is someone who has booked a holiday for a future travel date, and we want to steer their journey towards a positive outcome of them taking insurance before traveling. Or another example, someone who has visited a website and made an inquiry, and you want to encourage them to go on to make a purchase. In each case, behavioral modeling is learning from the characteristics of behaviors en route, seeing what people have done who have taken out these positive behaviors, and then we can recognize that in other customers. Another example looks at people who have responded to previous campaigns, so we can then identify those similar characteristics in other customers who can then be selected for a future campaign. So having characterized the behavior of people who, in our case, have taken insurance, we can observe other customers who have booked holidays, and as their journey unfolds, we can recognize behaviors. Perhaps, as we'll see in the example, people who have reserved sports activities. This is a behavior, a characteristic of those people who take out personal injury insurance. That will be our example. And so we can recognize that behavior and then send that person a well-targeted, well-timed communication that will steer them towards taking out insurance rather than traveling without. So let's see how this works, and I'll go on to a demo in FastStats. As I've said, we're going to be looking at a holidays example taken from our fictitious holiday business, and each booking record in our database has a booking date for the associated travel date. There's also now activity data in this database where some customers reserve activities for their upcoming holiday. Some customers also take out insurance in advance of the travel date. And then there's also the outbound communication data, and the challenge is to time this so that it's appropriate to the customer's journey. So I'll go through the 4 stages of the process, starting with understanding why people have behaved as they have in the past. And the first step here is to characterize patterns in past behavior for our given objective, which is people who've taken out insurance. and we'll use the time element in the data to first define customer journeys that we're interested in understanding, and then secondly to define behavioural features which will characterise the people who have taken out insurance. So in FastStats, I'll show you how we can create simple transaction level selections at the booking and policy level to define the journey. And these will be automatically converted by FastStats into powerful selections which select the analysis group and the base group. And this is done using a new dialog that was introduced in Q2 to help you compose this customer journey. And that dialog, as I say, will automatically create the analysis and base selections. These refer to what's known as a reference date, which is initially a historic training date as we look back into the past to learn from previous customers. That date will then be set to probably the current date to assess recent behavior to feed into a live campaign. And we may also use an evaluation date, which is an interim date, again, historic, where we can assess the accuracy of the model. So the base selection identifies people with a booking, in our case, up to 6 months before the reference date. And the analysis selection includes the additional requirement that they have an insurance policy within 3 months. Notice that the analysis are a subset of the base, and that there will be other people in the base who have insurance, but not within the time frame that we've set. Q2 improved the power of these event selections to cope with cases where people have other bookings that don't qualify, and you'll be in the analysis so long as one of your bookings is followed by insurance, in our case. So this gives us the two groups of people, and we're going to now compare their behaviours. And each behavioural feature that we create to compare the behaviour uses a time frame to identify what behaviour we're interested in. This could be relative to the booking date or the insurance date, or the period in between booking and travel. And the point is, we're looking at those specific dates for each individual when those events occurred along their own customer journeys. The use of the time frame to look between two dates is something that will become available next year, hopefully. We'll see. At the moment, you have to express the behavioural features relative to a single point in time, the booking or the insurance in our case. So we then go on to define the different behavioural features. For example, how many sports activities someone has reserved. And Q4 introduces new dialogues to make this process easier for you. There's still access to some of the previous menu options, particularly to automatically generate alternative features. And the ease with which you can create these features enables users to spend more of their time applying their business expertise, and as I say, allowing you to get more value from your data. So, for example, we might discover that the people who book insurance, they have booked more sports activities, these blue events in their journey. Or maybe it's longer since their previous insurance policy and they need to take out a new one. Or maybe it's something about the destination that they have booked their holiday to, etc. The e-guide, which is, as I say, available on the conference portal, describes different types of features. The main focus we'll look at today are the summary RFV features and how these can be turned into dynamic trends, looking at change over time. And something for a future release will be a focus more on perhaps the sequence of events and how these can be taken as clues to people's behaviour. So let me switch across to FastStats now. And I'm just going to start by showing an example of a standard modelling environment. So we don't have any date functionality set up here. Behavioural modelling hasn't yet been turned on. And we're going to compare here customers who have ever taken insurance against the whole customer base. But this illustrates how the modelling environment works. And we see here a number of variables, and we have a distribution in blue of all customers, and in green those who have at some point taken insurance. We could look at this by income and showing as a percentage the proportion of people who have taken insurance, and we can see that that increases into the higher income bands. Looking at the type of activity people have reserved, those people who have reserved sports activities, a higher proportion of them have taken insurance compared to those who are reserving tours. Similarly, the continent where you're traveling to, a higher proportion of those traveling to Asia and Africa have taken insurance compared to, say, Europe. If we flick back to looking at the count of people, although a high proportion of these people traveling to Asia and Africa take insurance, they're relatively few in number, so could be characterized as high quality prospects, but low in quantity. When we come to create a model, we'll use this PWE metric, which essentially is a score. And here we can see a strong positive score being given to people who have traveled to Asia and Africa, and a negative score to those who've traveled to Europe. So if I now switch to a behavioural modelling example. So here I've set to use the event-driven functionality. We've set the training date to be January this year. And I've already added two simple selections as I showed on the slides. So the insurance one is selecting people who have personal injury insurance or single trip insurance. And then within the modelling environment, I can use this new dialog to compose the customer journey and to select the analysis and base. So for the base, we want people who have any booking with the booking date, a number of months, 6 months, 6 months before the reference date, which will be January this year. And then for the analysis, we want them to also have an insurance policy with the policy date 3 months after the booking date. So you can compose selections with any number of events. For the time frame for our behavioural features, we want to look at the time up to the insurance policy for people in the analysis. And for those without an insurance policy, look at what they were doing around the time of the booking. So that creates the analysis and base selection for us, which, as we saw on the slides, is a powerful selection that composes that journey for us in FastStats. So back in the behavioural modelling environment, we can now move on to the second stage of creating behavioural features. And this is where we can use the new menus here to create RFV features, and the new menus in Q4 use dialogues to describe the behavioural features. So I could look at people's policies, insurance policies, and count the number of months since the date of the last policy. Q4 also allows you to pick the first as well as the last in terms of the recency. And we may want to restrict this to look at just policies over the last couple of years. So that creates us this behavioural feature. And if I just set that running, it will now go and analyse the behaviour. While it's doing that, let's create a second feature. This time looking at people's activities. Q4 allows you to also count distinct activities. But I'm just going to count how many activities someone reserved in the few months before taking out their insurance policy. And here we can use our business knowledge, what we've discovered that it's particularly sports activities that are relevant. And I can add a criteria based on the activity type, saying that we're just interested in sports activities. And that adds a criteria so that we're just counting sports. While that's building, let's look at the distribution here of when people took out their policy. Showing it as a percentage makes it easier to see that a lower proportion of people took insurance if they had a previous policy in the last 3 months. And those with policies longer ago are more likely to take out another policy. And showing that as a score, we would give these people a positive score and a negative score if they've recently taken out another insurance. And switching back to the count of activities, this confirms what we suspected, that people who have more sports activities are more likely to take insurance. Seeing it as a percentage perhaps raises the question, this group here, where only perhaps 10% have taken insurance, they have no sports activities in this time frame. But is that because they have reserved other types of activity, or have they perhaps not reserved any activity? Well, actually, the group contains both types of people. So what we might want to do is edit that feature and pick this option here, which is available once you've set the criteria, to distinguish those two groups. And now people who have no activity reserved at all in that 3-month period, they will be essentially excluded from the analysis by then being given a missing value. So I just build that. All the analysis tries to reuse previous results. So this should relatively quickly score people, removing those who have no activities reserved. And we can see now, if I flick between the two, that this group here, these are now people who have some activity reserved, but it's just not a sports activity. And that proportion who've taken insurance is higher than we perhaps thought, but there is still an uplift. Where it is a sports activity, that is still higher than the baseline. And so the PWE score is still a positive uplift if you've reserved sports activities. Just another option here, if I edit this feature again, we could have calculated the count actually as a proportion. So as a proportion of all the activities reserved, and this actually would have the same effect. If you have no activities in that time frame, we can't divide by 0, so that would also remove you from the analysis. So one final type, we could look at a value aggregation. And here, based on the bookings table, look at the average holiday length. And again, set the time frame to be just a few months before someone traveled or took insurance. And then we could use this change option to look at the change over time, perhaps thinking that someone's recent booking might be longer than usual, and that might prompt them to think about taking insurance. So we can compare the holiday length to their previous holidays. So we've here been focusing on sports activities. We can quickly generate, using some of the further options that were actually available in earlier releases, we can generate alternative features based on the other types of activity. So here, selecting the other 4 activities, I can create multiple features, which will give me 4 times 3, we're going to get 12 new features. One for each of the other activity types. And if I just set that building now, this illustrates one performance improvement that we added to Q3. This actually processes all those features in batches of 10, making it more responsive, bringing back the results as they happen. So I'll leave that running, switch back to the slides. And if you download the slides, there are screenshots of all that we've just seen there in FastStats. So the next stage of the process, having characterized those individual behavioral features, we're now going to combine those into a predictive model, which will enable us to recognize similar patterns in customers today. We're first going to build some alternative models and then evaluate which of those models is most effective. So the individual features that we have just identified, they're going to be fed into a model building process. This will again compare the behavior of our two groups of people, and the model will essentially find a way to rank individuals in terms of how likely they are to take insurance. And that ranking for a decision tree is based on rules. For example, we start here at the top of the tree with all our customers, and the first rule might separate out people who have more sports activities. A further rule might look at how long since their previous insurance policy. And we successively add rules, gradually concentrating people into the darker red nodes who are more likely to take insurance. Q1 this year introduced the support for, well, generally numeric variables and expressions, but allowing you to use the decision tree for behavioral modeling, and also a new visualization where the successive splits of the tree are shown by alternating vertical and horizontal splits, partitioning all our customers into smaller and smaller groups who are more and more likely to take insurance. A PWE model, on the other hand, combines these individual features using numeric scores. And so, for example, a customer who has a high proportion of sports activities reserved will be given a positive component towards their score. And they'll get another component based on how long since their previous insurance policy, and we'll gradually build up an overall score where the higher the score, the more likely that person is to take insurance. And we can create alternative models using different techniques, but in general, the better the features that you've developed, the better the prediction is going to be for whatever type of model. So spending the time exploring the features is time well invested in terms of creating an effective model. So the next stage then is having got a few alternative models to evaluate them. And just to summarize, we have used the January data, or the time leading up to that point, to train the model and to create these behavioral features. And we're going to use that same historic training date to now create a PWE and decision tree model. This will let us recognize people who might take insurance. And our ultimate goal is to use that on current data to score people for a live campaign. But what we're going to do next is apply the model to another historic period, July 21, look at the behavior leading up to that point in time, create predictions as to who we think might take insurance. And the key is we can then test those predictions because we know what did happen, and so we can evaluate the accuracy of our models. So let's just look at how we would do that in FastStats. So here's the features that are finished building. I'm just going to untick those ones. So in fact, the ones that we leave ticked are the ones that we can then carry through into either a PWE or a decision tree model. So this has just launched a it's a profile, but that's what we use to create the PWE model. It has copied across the analysis selection, copied across the features that we had ticked, and the base selection will also be copied in. And I can build this profile. It's going to use the January 21 training data. And this is now, again, comparing the two groups of customers. And for these 4 features, it's creating an overall score based on their behavior on each of the individual features. So these are the scores that we saw on the slides. You would get a positive score in this example if you have a previous policy a while ago. So that profile is finished building. If I go back to the behavioral modeling environment where we launched the profile from and go to the results tab, it has captured the result of that model here, run at 11:42. And in a minute, we will evaluate that model. But I'm just going to show you another book that already has a profile and a decision tree in it, just to show the decision tree. It's a bit more of an involved process, creating a decision tree. So it's a similar process in that launching a decision tree copies the analysis and base selections and copies the features. And this tree that I've built here, as we saw, starts with all customers. So we have a full fat donut and a portion here who have taken insurance. If I come down to this first level here, we've split people. Perhaps we've got about half the customers, and in these other nodes, we've got the rest. So in this node, we've got about half our customers, and over a quarter have taken insurance. Come down to another split. This has now included the rule based on how long since their insurance policy. We've got quite a niche segment, quite a thin donut, but over half have taken insurance. So the decision tree is effectively finding rules to rank our customers. So if I go back to this modeling environment that has the 2 models, I've already set the evaluation date here to be July, and I can run on the results tab, and that fills in this power figure for both models. This is a number between 0 and 1, and the higher value that we have for the decision tree suggests that's a better model. If I launch the model report tool and build that, it's again going to evaluate using the July data, or the data leading up to July. We get a tabular view with a lot of detail, but then also a graphical view where in green we have the decision tree and in yellow the PWE model. And essentially, the more curved these model lines are away from the gray baseline, the better the model. And if I select this point here, the model has ranked, as we say, the customer base. And so here I'm picking the top 4% as ranked by the model, top 4% of customers in terms of what the model thinks who will take insurance. And we can see by reading up the vertical axis that actually 25% of all the people who took insurance have been sort of concentrated into that node. So we have 4% of our base, but we actually have 25% of those who took insurance. So the model is doing a good job of identifying these people. So having evaluated the model and got confidence in it, we could then go back to the decision tree tool, and then this time launch a wizard to now score. I want to score all the nodes and all the records. And now I'm going to use a scoring date. So bringing that reference date right up to today. And in fact, using this option here will let me refresh this score variable on a regular basis and always assess the current behavior. And that will now create for me a score model that I can use to drive my campaigns. So again, there are some slides here that you can download. And then the final stage then is predicting and steering customers along the positive journey. We've created that model, we've tested it, we've just then applied it to create ourselves a score variable, and we can then use that to predict what people will do as we move into the future, and so steer people towards the best journey for them. And just to give an example then, well, to set the context first, we have evaluated our model based on July. We've just scored based on a current date. This is going to look at behavior right up to today and make a prediction as to who we should send personal injury insurance. That was the focus of this model. And then here I've got an example where I'm assuming we have a second model that has been trained and evaluated that is identifying people with the sort of behaviors that would suggest they should take family insurance. And having scored both models up to the current date, say, maybe the behavior of these three customers doesn't trigger any of those models to say that those people look like they need insurance as yet. But if we refresh the model scores next week, we may see that customer A fits the pattern of someone who we would recommend personal injury insurance. They've reserved these sports activities. Wait another week and perhaps customer C is picked up and given a high score by our second model, and so we would send them a campaign for family insurance. Wait a few more weeks and customer B, who we haven't contacted, neither of the models have picked up on them until now, and perhaps we then also send them the campaign and steer them towards that journey of taking personal injury insurance. So in summary then, the aim of behavioural modelling is to recognise behaviour that we've characterised in past customers, recognise that behaviour, choose when to intervene with current customers, and so steer their journey towards the most positive outcome. One final slide then just looks at how behavioural modelling itself has changed over time. And looking back to the talk I did 2 years ago, that laid the foundations in terms of being able to create these journey selections. At that point, it was always relative to a fixed date, but you could create dimensions. You could use that in the PWE model. Decision tree came this year, and then evaluating a model report. The main focus of last year has been the event-driven journeys, using different time points for each customer, depending on when the event happened for them. So Q2 introduced the dialogue for creating the journey selection. Q3 focused more on some performance improvements. Q4 coming out soon enables you to create the features more easily and adds a few different types. And actually it was Q1 that introduced the decision tree support. And then as we look to next year and beyond, the aim is to really automate more of this process, particularly within the dimensions, enabling you to generate and search for different alternatives, finding ways to better evaluate and look for the association, the relationship between features, making it easier to choose the features that are then built into models. And the end goal is to expose this in orbit, giving you a nice, easy way to pick the objective. So perhaps a customer journey wizard to create the customer journey, and then to discover some of these characteristic features and display those in orbit, and then give you an easy way to automatically target those customers and to turn that into action through people stage. So that's all we've got time for today. If there are any questions, I think we might have a minute or so now. Otherwise, I'll get back to you. And also feel free to contact us via email as well, if that's easier.
Hi, Ray. We have just the one question from Lloyd,
Yes.
who points out that expressions are already supported in the modeling environment, and asks if we have plans to be able to create expression features that behave like selectors. He kindly gives us an example, a feature that gets a person's most common activity type, or to create recency variables on other selector-based data.
Yeah, that is a good question, in that the recency that I showed and that is supported is for numeric variables. And this is asking whether we could look at the most recent, for example, product type. And as Lloyd points out, using the expressions could be the way to do that. So yeah, there definitely are plans, and I do see that as something that would be very useful. And we'll hope to include, it's not there yet because the way the server works, it's not quite as easy as for numeric variables, but yes, definitely that is something that I recognize is useful and would like to support.
Thank you. And that's it for the questions, Ray. Thank you.
Okay, well, thank you, everyone. And as I say, you can download the e-guide from the conference portal or Apteco's website. But enjoy the rest of the conference. Thank you.